Hello students, today we'll be discussing about the impurities. That is one of the important chapter for pharmacology and pharmacy. So you know very well what is impurity. We know impurity is a substance which can be defined as the unwanted foreign substance or unwanted substance which can result the efficiency of any drug or any substance that should not be present in our body, that should not be present in any drug. So there should be impurities and limit test will be discussed in our class. So this is for the inorganic chemistry, and these impurities are very general for all the chapters. Actually, impurity is many substances can contain different unwanted substance or impure substance which is not required. Okay, so our objective is to remove impurity and to highlight where the impurity is present, and we should be looking after that there should not be any impure substance or that should not be arises from the impurity. Now directly going to the definition of the impurities. So an impurity is a substance that is not pure, meaning it contains unwanted foreign matrix or is mixed with other substances that makes it less pure or lower quality. So impurity can be physical like dirt, debris, or the chemicals like unwanted molecules in a compound. The presence of impurities can affect the properties and properties of substance. Actually, impurity may be different physical, uh, different solvents like this. Right. So they can affect the property as well as performance of substance. Suppose any impurity is present in any salt, so the property will be changing and the activity will also be changing. Now, classification of impurity. So impurities can be classified in the following categories: organic impurity, inorganic impurity, and residual solvents. Actually, this impurity can be coming from different fact. So organic impurity is a process and drug, and inorganic impurity that is a residual solvent, and they are coming from the different processes as well. Just 1 second, whenever I'm showing the slideshow, it's not showing, so I'm showing the present step like this way. Now coming to the organic impurities. So here organic impurities can arise during the manufacturing process and or storage of the new drug substance. They can be defined or undefined, volatile or non-volatile, and include starting material, byproducts, intermediate, finished product, reagent, ligands, and catalyst. That means impurity or organic impurity whenever any manufacturing process of the drug or any solution or any capsule or any syrup is prepared can be arise during the manufacturing process. And if the drug is stored for a longer time, that can be also put to some. So they can be easily identified, not easily identified, can be volatile, non-volatile, and what are the different sources from impurity can be coming, like the starting material, byproducts, intermediates. Whenever any product is synthesized, there are some byproducts which can be mixed through it. Whenever any intermediate is synthesis, that can be mixed through. Okay. Next, degradation product. Whenever the product is stored for a longer time, degradation product may also mix with that. Next, to check reagent, ligands. Different reagent can have the impurity. Different ligands is also present in our body, like this. Now, catalyst. Some catalyst which play the reaction faster. If it is not properly removed, they can also be used. Okay, it's coming to the inorganic impurity. So that inorganic impurities can result from the manufacturing process. They are normally known and identified in reagent, ligand, and catalyst. They can arise from the reagents which reagents are used. Okay. And next, heavy metals or other material residual metals. So different heavy metals which is used in manufacturing container that can be used. Okay. Next, inorganic salts. Inorganic salt which are used. Okay. And which can be arise due to the manufacturing. They can be just different inorganic salts. Also. Next, other materials like the fish eggs, charcoal. So these are the different important inorganic materials also. They can also be the red substance. Now coming to the residual solvent, like solvents which are used for the inorganic or organic as liquids used as vehicle, that's a medium for preparation of drug solution or suspension. They can be recite that solvent whenever the like we need 100 ml or we need 500 ml. But if excess amount of present in that of the form, they can also produce impurity upon reaction. Next, residual solvents in pharmaceutical are defined as the organic volatile chemicals that are used or produced in the manufacture of drug substances. So they can also cause us different problems. Now, sources of impurity. Where the impurities are coming, that is very common. Raw materials, it is employed in the manufacturing, method of the process used in the manufacture, then chemical process and the plant materials employed in the process, then storage condition, then decomposition of the current process, the impurities. Effect of impurities in pharmaceuticals. Impurities may bring about compatibility with substances. So what are the problem will be here? If the impure substances are present, they will be produced as incompatible. They will not be mixed with the substance. And impurities will lower the shelf life of the substance. When that means the shelf life means the time for a longer time where the drug will be safe and there will be not any degradation. This is known as the shelf life. How long the drug can be stored. And if the impurity is there, the shelf life will be lowered. Impurities may cause difficulties due to formulation of substances. They can cause the difficulties during the manufacturing process of the substances. Okay. So, and sometimes impurities change the physical and chemical properties of the substance also. Right? Therapeutic effect can be decreased, shows toxic effect after a certain injurious when present above a certain dose. It may change odor, color, taste of the substance also. Okay. Now, one by one, we will be learning the different tests. So, in our syllabus, there is a test of chloride, test of sulfate, test of arsenic, and test of iron. Okay. Now, for chloride limit test, there is a principle of the reaction. Limit test of chloride is based on the reaction of soluble chloride with silver nitrate in the presence of dilute nitric acid or silver chloride, which appears as a solid particle or opalescence in the solution. That means if we take the standard sodium chloride and silver nitrate is added to that substance and a small amount of solution is added, it will produce AgCl, silver chloride, and that will be precipitated towards the test tube. It will be producing the turbidity or opalescence throughout the solution and it will be showing a lot of solid right present in that solution. Right? There is a principle. Now the procedure that will be discussed and that will be performed on our lab also. So that will be done in our lab. So in case of substance sample and there is standard. So that is prepared. So in case of standard, you should take 0.0585% of WI solution of sodium chloride in the cylinder. Then 1 volume of nitric acid here. Then it will be diluted with water in Nestle cylinder. Then it will be added to silver nitrate 1 ml and it will be kept aside for 5 minutes. And we have to check the observance of the opalescence. The same procedure is followed for test sample also. Here test sample water take or any test sample solution that will be taken in the cylinder and the rest around this nitric acid addition, dilution, silver nitrate addition. Every procedure is same. Now we should observe the results. The opalescence produced in the sample solution should not be greater than the standard solution. If opalescence produces in sample solution is less than the standard solution, the sample is the limit test of chloride. Because results. Nitric acid is added in the limit test of chloride to make the solution acidic and helps silver chloride distributed to the process. In case of standard solution, chloride is more than the standard, then the solution is Now coming to the limit test of sulfate, that is also important. Here, limit test of sulfate is based on the reaction of solute sulfate with barium chloride in the presence of dilute SaO2 and sulfate is reacted. It will produces BSO4, which appears as a solid particles or turbidity solution. So the solution will produce barium sulfate, which will become turbid solution. The procedure. Same procedure, like same test and same standard procedure. Some standard amount of solution of potassium sulfate is taken as a cylinder. Then 2 ml dilute acid is added. Then dilute to 45 ml in the cylinder, and 5 ml of barium sulfate reagent is added, and keep aside for 5 minutes. Then we should observe the turbidity. Now, if the turbidity of the test sulfate is more than the standard sulfate, then the that will fail. And if it is equal to that standard sulfate, so it will pass. If it is below the pass marks or below the less amount of standard, that will be passing. So up to this, or we can say the limit test of iron and limit test of arsen. Okay, let's see the procedure of arsenic here. Okay, whatever we will be discussing later on. Okay. So up to this here, I'm concluding the chapter. Thank you everyone. Thank you for your questions.